Good morning. I'm Zachery Butler, and today we're going to be talking about linear equations and linear inequalities. So before we start, I want to go over some things about what these are. So to start off with, we have some vocabulary. We have equation. Now, what is an equation? Everyone knows what an equation is. It's two mathematical expressions that are made to be equal. We'll give an example of that in a minute here. Then there's also inequality. Now, an inequality is similar to an equation, except the expressions are not equal. They are showing that they are not equal and they are different values from each other on the different sides of the expression. So to begin with, we're going to start with a linear equation. So we have a linear equation here. You have a variable. This is a linear equation in one variable. You have a variable, you have a constant, and then you have your answer. So in order to solve for a linear equation, you have to go through different operations in order to find the value of C. So for this linear equation, we're using C, and to solve a linear equation, we find C, which is the variable. So if I have C plus 1 is equivalent to 12, that means that this value right here, whatever it is, adding 1 is equal to 12. So if we do some reverse operations here, if we are to move this 1 onto the right side, we have to subtract 1. So in order to get rid of the 1 on this side, we subtract 1 on the left side, and whatever you do to the left side, you must do to the right side. Therefore, you subtract 1 on the right side as well. So if you do the math, then C is equivalent to 11. Okay, that was pretty simple, pretty straightforward. This is just to introduce you to the idea of how to solve linear equations. Now, the next one is a two-step linear equation, but it still has one variable. So in order for us to solve for the variable, which is x is our variable, 8 is the value that this expression is supposed to equal. So in order to do this, there's a couple things that we have to do first. We have this nasty little division right here. We want to get rid of that. So in order to get rid of that, we do some reverse operations. So if x is divided by 6, in order to get rid of that 6, we multiply this side of the equation by 6. So I'm just going to rewrite this down here to make it a little more neat. So x over 6 plus 2 is equivalent to 8. So if we multiply this by 6, then these two cancel out, leaving only x. But remember, whatever you do to the left side, you must do to the right side. So 8 times 6, that leaves us with x plus 2 is equivalent to 8 times 6 is 48. So now we are back to the same situation we were at before on the first example. So in order to find the value of x, we have to get rid of the 2. In order to get rid of the 2, we have to do some reverse operations. So we subtract 2 from 48. And that will give you the value of x. Linear equations, solving for linear equations, relatively easy. It can get more complex as you start adding more variables and adding exponents and quadratic equations and such, but today we're going to keep it a little simple as an introductory video. So we talked about linear equations. Next we have linear inequalities. So what in a linear inequality is determined by is the sign. So in a linear equation, this is a linear equation. It is equal is synonymal to equal. So in a linear equation, we have the equal sign. That means that the left side is equivalent to the right side. However, in a linear inequality, we have some new signs here. Now these signs make all the difference, especially when it comes to graphing the equation on a line. So just a quick side note to go over what these signs mean. This sign means that the left side is less than the right side. So this one right here is the less than sign. This side means that the left side is greater than the right side. So this is the greater than sign. Pretty simple. Now we start getting into greater than or equal to, and this is where it's going to determine how you graph the inequality on a number line. So then we have greater than or equal to. This little line underneath means that it can be greater than or equal to the value. And then similarly, we have less than or equal to, which is the same thing. So now let's see this in practice. On linear inequality, we have this multi-step function right, or multi-step equation right here. So our sign is less than. So the left-hand side, LHS, is less than the right-hand side, RHS. There is no equality in there. It is not less than or equal to. It is just less than. So whenever we graph the line, we are going to draw it with an open circle. I'll get to that in a second here. First, let's go ahead and solve for this inequality. So we saw how we solved for the linear equations. Solving for a linear equality is the exact same process. So we have a multi-step left-hand side right now. So let's go ahead and figure this left-hand side out, and then we'll isolate the x and find what the value is compared to the right-hand side. So if we distribute the 2, we get 12x minus 10 is less than, well, let me draw a better less than sign, 14. So because we're not getting rid of anything, it's only the distributive property, we don't have to do this to the right-hand side. Whenever we start trying to do inverse operations is when we have to start adding things to the right-hand side. So we have 12x minus 10. So now this is just a normal two-step equation. So in order to get rid of the 10, which is what we need to do first, because this is a minus here, we need to add 10. So we add 10 to the right-hand side. This leaves us with 12x is less than 24. Now, in order to isolate the x, we have to get rid of the 12. Now, because the 12 is multiplied by x, how do we do that? We divide. We divide x by 12, canceling these out. But what we do to the left-hand side, we must do to the right-hand side. We divide 24 by 12, and that gives us x is less than 12. Oh, I apologize. X is less than 2. So we have our number line here. The number on both sides of the 0, we have negative integers and positive integers. So if x is less than 2, 2 is where we're going to start our graph of the number line. Now because this symbol right here, it is less than and not less than or equal to, and that means we draw an open circle on the 2 value. Now, if x is less than 2, then while looking at the number line, we need to recognize which side of the number line corresponds to less than that value. Oh, excuse me. So if x is less than 2, then it needs to be going below 2, which is moving towards the negative integer side. So after drawing your large circle, you're going to draw a thicker line to show that the value is not 2, but less than 2. And this is how you are to graph linear inequality on a number line. Now, let's move into something, it's another multi-step linear inequality. However, we have a different sign. We have a sign of greater than or equal to. So now we flipped it and added the equal to portion. So but first, before we get into graphing the number line and all that, let's solve for this problem. So we have 7x plus 1 over 3 is greater than or equal to 5. So to begin with, we need to get rid of this 3. This 3 is going to throw everything off, so we want to always take care of the division first. So in order to get rid of the 3, we do inverse operations. We multiply it by 3 on the left-hand side, which means we have to do it on the right-hand side. So these cancel out. These multiply together. That leaves us with 7x plus 1 is greater than or equal to 15. So 7x plus 1 is greater than or equal to 15. Now, in order for us to isolate the x, we have to drop the 1 and divide by the constant. So we drop the 1, you minus on the left side, you drop the 1 on the right side. That leaves us with 7x is greater than or equal to 14. Now, from previous examples, we know what comes next. Divide by 7, divide by 7. This gives us x is greater than or equal to 2. So whenever we are graphing this on the number line, because this sign is greater than or equal to, that equal to portion is important, especially when it comes to graphing on the number line. Now if it is equal to, then we start with the value and we draw a dark circle. We fill in that circle to show that this value is inside of the scope of the equation. So if x is greater than or equal to 2, we need to find out which way the number line is supposed to be going. So if it is greater than or equal to 2, then the number line's graph needs to be moving to the right and increasing in size, not decreasing. So, in essence, this is how you solve linear equations and solve your linear inequalities. Some main points that you want to remember is that equations are, the left-hand side is equal to the right-hand side. The inequalities are the left-hand side is not equal to, but is represented in a different way than the right-hand side. In order to represent this, we use our greater than, less than or equal to, I'm sorry, I have that backwards. Our less than, greater than or equal to, or less than and equal to signs. Then, after we get done solving for the linear inequality, we want to be able to graph the linear inequality, the value of x. This has been a quick lesson introduction to solving linear equations and linear inequalities. I'm Zachery Butler. Thank you.